Hi, welcome to my channel EasyML. In the previous video, I introduced the concept of correlation coefficient. In this video, we will take a look at what is the best way to represent those correlation coefficients. A convenient way to represent correlation coefficient amongst variables is through a correlation matrix. Here, on the left, we have a correlation matrix. A correlation matrix is a table that shows the correlation coefficients between different set of variables. Before interpreting the correlation matrix, let us understand a little more about the interpretation of correlation coefficients. As I mentioned previously, and as you can see on the correlation spectrum here, the correlation coefficient is measured on a scale of -1 to 1. Now let us try and interpret the table on the right, highlighted in red. We say that two variables are perfectly correlated when the correlation coefficient is between 0.9 to 1 or -0.9 to -1. It is the area highlighted in green in the correlation spectrum. Now, we say that two variables have a strong correlation when the correlation coefficient is between 0.5 to 0.9 or -0.5 to -0.9. This is the area highlighted in yellow in the correlation spectrum. Moving on, we say that two variables have a weak correlation when the correlation coefficient is between 0.1 to 0.5 or -0.1 to -0.5. This is the orange area highlighted in the correlation spectrum. Lastly, if the correlation coefficient is somewhere between 0 to 0.1 or 0 to -0.1, it literally suggests no correlation. That is the area in the red in the correlation spectrum. Now let us go to the correlation matrix. Let us say we select height. Now, height is obviously going to be perfectly correlated with itself. Hence, the correlation of height and height happens to be 1. Now, height and weight have a correlation of 0.87, which, according to the table on the right, means that there is a strong correlation between these two variables. Height and age have a correlation of 0.65, which again, according to the table, suggests a strong correlation. This is how we interpret the correlation matrix. Now this brings us to question that if correlation helps understand the degree of association between variables, why do we need regression models as such? Stay tuned to the next video to find out more. Thank you.